Section 2, Standards of Measurement. Your essential questions, there's 4 of them this time for 1.2. What is a standard of measurement? What multiple of 10 does each SI prefix represent? What are the SI units and symbols for length, volume, mass, density, time, and temperature? And how can related SI units be converted? Suppose you and a friend want to find out whether a desk will fit through a doorway. You have no ruler, so you decide to use your hands as measuring tools. Using the width of your hands, your friend measures the doorway and says it is 8 hands wide. Using the widths of your hands, you can measure the desk and find it is 7 3/4 hands wide. Will the desk fit through the doorway? You can't be sure. Even though you used both hands to measure, you didn't check to see whether your hands were the same width as your friend's hands. In other words, because you didn't use a measurement standard, underline standard, you can't compare the measurements. A standard is an exact quantity that people agree to use to compare measurements. For a measurement to make sense, it must include a number and a unit, as shown in the figure. Your family might buy lumber by the foot, milk by the gallon, and potatoes by the pound. These measurement units are part of the English system of measurement, which is commonly used in the United States. Most other nations use the metric system, a system of measurement based on multiples of 10. The word length is used in many ways. For example, the length of a novel is the number of pages or words it contains. In scientific measurement, however, length is the distance between 2 points. That distance might be the diameter of a hair or the distance from Earth to the moon. The SI base unit of length is a meter. A baseball bat is about 1 meter long. Metric rulers and meter sticks are used to measure length. The figure below compares a meter and a yard. And while we're here, we will never, ever, 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 ever measure the American way, which is in inches. We will be using the meter system exclusively. The amount of space occupied by an object is called its volume. If you want to know the volume of a solid rectangle, such as a brick, you measure its length, width, and height, and multiply the 3 numbers and their units together. For a brick, your length measurements would most likely be in centimeters. The volume would be expressed in cubic centimeters, because when you multiply, you add the exponents. To find out how large of a load a moving van can carry, your length measurements would probably be in meters, and the volume would be expressed again in cubic meters. Mass is a measurement of the quantity of matter in an object. The mass of the golf ball is about 45 grams. It is almost 18 times the mass of the table tennis ball, which is about 2.5 grams. A bowling ball has a mass of about 5,000 grams. This makes its mass roughly 100 times greater than the mass of the golf ball and 2,000 times greater than that of a tennis ball's mass. Density is the mass per unit volume of a material. You find density by dividing an object's mass by the object's volume. For example, the density of an object having a mass of 10 grams and a volume of 2 is 5 grams, centimeters to the third. Now listen, we're not going to go heavy in math with this first chapter, but I guarantee you we will be doing a lot of math with formulas by the end of this semester and then throughout the rest of the year. That way everybody has a chance to catch up and be on the same page where math is concerned. So these things you need to memorize, and a lot of them are throwback from middle school. It is often necessary to keep track of how long it takes for something to happen. Time is the interval between 2 events. The SI unit for time is not minutes, it's seconds. In the laboratory, you will use a stopwatch or a clock with a second hand to measure time. Another type of measurement common to science is temperature. You will learn the specific meaning of the word temperature in a later chapter, but for now, think of temperature as a measure of how hot or cold something is.
1. Water. 2. A 250 milliliter
We are looking at how to find out or determine the density of a pencil.
Graduated cylinder. 3. An unsharpened pencil. 4. A balance. And 5. Your science journal. For your safety, please wear your goggles and an apron during this activity. For this activity, follow these procedures. 1. Measure the mass of an unsharpened pencil in grams. And 2. Put 90 milliliters of water into a 100 milliliter graduated cylinder. Lower the pencil, eraser end down, into the cylinder. Push the pencil until it is just submerged. This is known as water displacement. Hold it there and read the new volume to the nearest tenth of a milliliter. In your science journal, write your analysis for this activity. 1. Calculate the pencil's density by dividing its mass by the change in volume of the water level.
So as you can see,
And 2.
math
Is the density of the pencil greater than or less than the density of water?
is not going to
How
go
do you
away.
know? The expected outcomes for this activity are: 1. Students should use the equation D equals M divided by V. Remind them that 1 milliliter equals 1 cubic centimeter. And 2. Because the pencil floats, its density is less than that of water. Also, its calculated density is less than that of water, 1.0.